All right, so continuing in on Unit 10, what we're going to look at next is a rectangle. So when we talk about a rectangle, what we're looking at is still a parallelogram. So if we think about what we did all the week we studied about parallelograms, all those properties are still true. But when we talk about a rectangle, what we're looking at is a parallelogram. And instead of like a rhombus that had 4 congruent sides, this is a parallelogram with 4 right angles. All right, so just like our parallelogram and our rhombus, we get to say some of the same things. So we get to say opposite sides are congruent. All right, so we get to say congruent here. We get to still say parallel. We still have opposite angles or congruent. We still have consecutive angles supplementary. And we still know that the diagonals bisect each other. But let's talk about what's unique to a rectangle. So when we think about what's going to be unique to a rectangle, what we have is 4 right angles. All right, so that was something that a rhombus didn't have. So a rhombus did not have this. Okay. The other thing that is not true of a rhombus, that's true of a rectangle, is that the diagonals are actually congruent. So if we have 2 equal segments cutting each other in half, instead of having to do like we did with the rhombus where we put tick marks here and then a different number of tick marks here, we actually get to say all of these lengths are exactly the same. All right, so that's what's unique to a rectangle. Now, I'm going to fill in some generic angles here just to make sure we understand one of the concepts that's very important. When we were looking at our rhombus, if I put a 30 degrees here, then with a rhombus, we would have said 30, 30. Well, this is one of the big differences because when it's a rectangle, I need these 2 angles to be complementary. I need them to add up to 90 degrees. So if this is 30, this has to be 60. All right. Now, just like our rhombus, given 2 of the angles, I can actually work my way around because what I want you guys to maybe notice here is that we have, oops, let me get rid of that. What we have here are isosceles triangles. So if I look here, this is actually an isosceles triangle. And remember when we did isosceles triangles, we learned that the base angles are going to be congruent to each other. So if this is 30, this has to be 30. And likewise, I could also say that if those 2 are 30, then these 2 are 30, because it's just the same triangle flipped up, which then also tells me that I have 60 and 60 and 60. All right, now a couple of the side measurements. If I told you that this length was 5, then you could tell me all of these lengths were 5 because they're all going to be the same. And the other side of it is these 2 lengths have to equal each other. Opposite sides are going to be congruent. And then those sides would be congruent also. Let's go ahead and look at our rectangle examples. So notice here, the pictures are not drawn for you. And I can't stress enough in this class, if you don't have a picture, you need to draw the picture so you can see what we're dealing with. So if I draw a picture of a rectangle, then let's go ahead and look here. It tells us to name our quadrilateral RSTU. And it says the diagonals intersect at P. So I'm going to go ahead and draw the diagonals in. And we're going to have that they cross at P. So let me go ahead and get this. Okay. So if the measure of RSU, so that's this here is a 3x minus 5, and UST, so that's this guy, is 4x plus 4. Find the value of x. So here's the trick. This is not a rhombus. If this was a rhombus, we would actually just set these two equal to each other, right? If this was a rhombus, then I would say the diagonals bisect this angle. This is not. This is a rectangle, which means these two angles over here are complementary. They make a 90-degree angle. So we are going back and using our Q1 skills of knowing what we do with two angles that are complementary. And when we see that, we add them up to equal 90 degrees. So 7x minus 1 equals 90. So 7x equals a 91. When I divide by 7, we would have a 91 divided by 7, and we get 13. So x is 13. All right. So our second example, same thing. I don't have a picture, so we're going to draw a picture. So I'm going to get a rectangle. I'm going to draw my diagonals in, because once again, we're doing a problem with diagonals intersecting at P. So we would say we have A, B, C, D intersect at P. And let's see, AC, so the whole length of this side is 4x minus 13. And then they tell me this little piece is an x plus 7. All right, so remember our property of rectangles is the diagonals are actually congruent to each other. So whatever this length is going to equal the length of BD. The problem is I only know this part of BD, but remember with all parallelograms, diagonals bisect each other. So that means this is an x plus 7 also. So what I really have here is a 2x plus 14. So I would say 2x plus 14, because an x plus an x and a 7 plus a 7 equals a 4x minus 13. So let's go ahead and solve this. So I would subtract the 2x over, and I would get a 2x. I would add the 13 over, so I would get a 27, and then we would divide by 2, and so I would get x is a 13.5. All right, so last one, let's go ahead and draw in our rectangle. Quadrilateral, J, K, L, M. We have our diagonals intersecting again at P. All right, you can probably hear my children in the background. All right. So LP is 3x plus 7, and MK is 26. So actually, this is exactly the same type of problem we just did. MK is the full length of the diagonal. LP is only half of it. So what I would have to actually do here is the same thing. If this is 3x plus 7, if this is 3x plus 7, then that also means this is 3x plus 7. So I would say I have a 6x plus 14 equals 26, right? Because if I have a 3x plus 7 plus a 3x plus 7, that's where I'm getting this 6x plus 14. So 6x equals a 12, and so x equals 2. And that's my final answer.